Hey, hello, and welcome to the show. It's me, John Park, and this is John Park's Workshop. All of this and more. Thank you so much for stopping by. We've got people over in our chat. Hello to the YouTube chatters, Johnny Bergdahl, Batagraf, Avdel Hagen, and possibly others as they arrive. And, of course, our Discord chat. If you want to go join in on the fun there, look for that live broadcast chat channel in our Discord. You can find that at adafruit.it/Discord. That'll give you an instant invite link to the server. Lots and lots of different channels there with lots of great people doing interesting stuff, chatting about things. But during the show, during live streams, that's a good place to be right there, live broadcast chat. Hello to Liz, Johnny Bergdahl, Squid.jpg, C. Grover. Thanks, everyone, for popping by. Let's see, what's going on here today? I've got a coupon code for you so you can save some money in the shop. I've got a recap of the product pick of the week. I have a highly snazzy, in my opinion, CircuitPython Parsec, and one that I'll also extend out into some future parsecs because I think it's an interesting topic. Hope you do too. And then we're going to dive into the guts of that thing that you can see off on the edge there. It's the wall-mounted Pico 8 arcade machine, and I'm gonna show you how to put that thing together. I'm excited about it. It's I think something that you might enjoy building and gifting to someone or hanging on your wall and playing if you're into these types of games. You can also extend it out to lots of other LED matrix uses, and I think it is attractive and fairly straightforward to put together. So I'm excited about that one. So starting off, I mentioned a coupon code. So if you head over to the Adafruit shop at adafruit.com, find some things you like, throw them in the cart. You can use today's coupon code for 10% off. It is artwork. I figure that this is sort of like a piece of artwork. So there you go. That's the coupon code that you can use. Look at all the good stuff. If you head over to Adafruit, that's not it. That was me looking for a thing on GitHub. If you head over to Adafruit, right here is the shop. You're immediately there. And if you want to look at some little drop downs like new products or featured products, gift ideas, some different categories here. If you head to the first one there, new products, that'll show you some neat new stuff. How about this cool Pimeroni thing? Tiny FX. That looks neat. Reminds me of some of the Lego lighting kits that are out there, not made by Lego, but made by third-party companies. I think that's part of the idea there is Lego and model lighting. It looks pretty snazzy. And let's suppose you wanted to buy that, but you wished that it were $4.895 less. Well, then just use this coupon code because that's going to take, with some amount of rounding, that's going to take 10% off. Use that coupon code in the little coupon code field. And that is good until midnight tonight, East Coast time. I can tell you precisely when it expires. So go get some neat stuff. Let's see. Hello, some other people who just joined us. Hey there, Thin Man. Jim Hendrickson, hello. John Nodge, thanks for popping in. All right, so next thing, this show from Tuesday, my product pick show. I pick a neat thing. I give you a demo. I give you a huge discount along with of course, the help of the new products team. We're able to stash 100 of them off in the side before the show, then release them like so many bees and give you, in this case, 50% off. Here is a little recap from this week's show. It is the DAC 6578 10-bit 8-channel I2C digital to analog converter breakout. It's the DAC 6578 breakout. It's connected over I2C. And then I've just run common ground and each of those analog pins to their own socket there. So I've plugged in patch cables to those. Those are then running up to different channels on this little Eurorack synthesizer. We have this nice smooth sine wave at the top and then a faster one at the bottom. Just the first one, you might be able to see the pitch, the relative pitch going up and down of that note. And the bottom is the envelope. 4 channels of control voltage coming in here, playing 4 different notes, and we have 4 channels of that amplification. It is the DAC 6578. It is an 8-channel, 10-bit digital to analog converter breakout with I2C. Yes, it is. So next up, let's keep this thing rolling, shall we? Next up, I've got a CircuitPython Parsec. Hey. CircuitPython Parsec. Okay, so here it is. Look at this. For the CircuitPython Parsec today, I wanted to talk about using ANSI escape sequences for text formatting inside of the REPL. So a lot of times you are doing some kind of debugging with your CircuitPython hardware in your REPL, and you need to read some text, some data that's coming out, some sensor readings. The typical method that you'll see when you just fire up a REPL and run your code will look something like this. So I'm printing the word howdy, I'm incrementing I, so that number is just going up and up and up. I'm printing the word time, and then I've got the time monotonic value also just continuously marching upward. If your data is streaming pretty fast, if there are multiple things, it can be difficult to see what's going on. You don't always need a big long history. In fact, sometimes you just want to see a number showing up or some bit of info showing up in front of you. How do you do that? Well, you can do that with an ANSI escape sequence. So I'm going to go ahead and comment out and in some lines of code here. This was the initial line here. It just said print I time monotonic. Now what I'm doing is first printing the ANSI escape code, and that's this /x1b that says, hey, we're about to do something other than just printing. We're going to run a command in the console here. The first one I'm going to do is going to home my cursor. So bracket H puts the cursor in the upper left position here. And then I'm going to clear the screen. And then I'm going to go ahead and print my line as before. So watch what this does when I resave this. You can see now it's just printing that one line in the same space, clearing it out, putting the cursor back at the beginning, and now I get a easier to read readout of this information. Now you can do a little bit more. So I'm going to keep that initial sequence that has the escape code, the cursor home, clears the screen. But this time I'm going to do some color coding. So again, in this line, print and then /x1b, the escape sequence, and then bracket and a color number. In this case, I'm doing 34M. That says I'm going to change the color of the text. There's a little list that I can show you of some of the color values you can use in your console. A lot of this will vary depending on the console you're using and if you have any themes applied. So then I'm printing a word, the incrementing I. And then I'm using another escape sequence code, color code. This is a different color. So 34 was the howdy, 31 is the word time. And then at the end of this, I get out of. So escape sequence 0M, that means any subsequent text will be normal. So I'll go ahead and save this. And now you see I've got howdy and the I value in blue, and then time and the time monotonic value in red. And there are some even fancier things we can do. I'll just do one more set here where, again, I'm going to set the color codes, but I'm also going to use a code for bolding text and highlighting text. So if I resave this, now you can see I'm also underlining the text. So howdy and the I are underlined and in blue, and then I've got the word time inverted in a highlighted color. So you can find these ANSI codes. They aren't specific to CircuitPython. These have been around for a long, long time, since the 70s. If you look for these online, you'll find some things like color codes. I've got a set of them here for black, red, green, yellow, blue, magenta. Some consoles will use anywhere from 0 to 255 and let you pick your own color, as well as some tricks like bolding, dimming. Italic doesn't work in every one, doesn't work in the one I use. Underlined usually works, inverting colors. So there's a lot of fancy tricks you can do with this, and it just makes life a lot easier when you are displaying text in the REPL. And that is how you can use ANSI escape sequences to format text in the REPL in CircuitPython. And that is your CircuitPython Parsec. Some questions and thoughts from the chat. I'll bring up the chat right here. C. Grover says, very VT100 terminal-esque for sure. John Nodge and Squid like the trick. Thank you, I'm glad you do. C. Grover says, does the REPL font have the VT100 ANSI line drawing forms and characters? I have used a solid block character. I'm not sure if it has some of the other like little angle bracket ones. I suspect it does. If you know codes for those, we can try those out. I actually have another of these planned next week that uses a little bit more of the cursor movement stuff in order to be able to sort of draw a bar graph that's active on screen. I haven't tried these on REPL built onto a screen, a TFT for example, but I suspect that some of them will work and some of them won't, depending on the screen that you have. So try it out, play around with those. The real key thing is just the initial getting started with the escape sequence X1B, or you can do that in octal as 033, I think it is, but I decided to use the hex because it seems a little more common these days. There you go. Jim Henriksen says, that's a handy little trick. I'm always printing out huge lists of output and then scrolling up. Yeah, when you're trying to find the thing. These are, let me show my screen again. These are, I believe, yeah, this will preserve, my REPL here will preserve the history up until when I use the ANSI escape code to clear it. So you'll see these aren't changing anymore after I started doing that. You can also log things too if you want to write out logs to a SD card while making your printout a little more digestible. Then you have a list you can reference. That might be a nice way too, depending on the type of stuff you're doing. All right. Hello to Richard Balog in the chat over on YouTube. Thanks for stopping by. Howdy. All right. In fact, you know what? Let me do a little bonus thing with this. I'm going to go adjust my code here. Let's just do... I'm going to do this... I'm going to comment out all of this. And let me see if I... There we go, that'll work. So these were just my little notes to myself here. So some text colors, you can see that the only difference between these lines other than the actual text that's being printed out are these color numbers. So 30 is black. You don't see anything there probably until I highlight it. You can do a little secret text there. The 31 red, 32 green, 33 yellow, and on and on. Those don't all match my REPL here because I have a color theme applied, excuse me, on my copy of Z here that I'm running. So some of those are like magenta is showing up as gray in this case. Let's see, we can also do some of these right here. So you can see bold works, dimmed works. Oh, that's funny. Italic works here, and it didn't work on my other computer, even though both are running Z. That's weird. I don't know why. Hey, that italics looks really nice. It might be the font that's picked for the console. I think it's the same console that it's running. It should be. It's just whatever default comes from Z here. Jim asks, do you have a cheat sheet for all the escape codes? I don't. I bet that there's some nice websites with those references. I'll post this code, though, including these ones that I've done here, if that's helpful. And here's some nice highlight color ones. So you can do foreground color, which in this case is set to white, and then the background colors are 10 above the text colors. So 31 gives you red text, 41 gives you a red background. You could red the whole thing out if you did the text red and the background red again to do hidden stuff, like you can see here with this white on white example. Juliana, says, I used your old example of mouse ANSI acceleration for RP2040, but the scroll up and down are not working. Let me see if I can. I'm not sure what is happening with that. Looks like it's a question. Maybe ask that question over in help with Arduino, if that's in Arduino, or help with CircuitPython, if that's in CircuitPython. I'm seeing an Arduino serial port there, so maybe that's what you're using. Not sure which example that is. All right. So hey, thanks for indulging me with some of that cool ANSI text stuff, and I have some ANSI graphic kind of things that I'll bring in next week. Okay, now it's time to dive into this guy right here. So I'm gonna switch over to this camera to demo. I'll just put myself in the corner here. So what's going on here? I've got we looked at last week, I had just gotten a couple of these IKEA frames, the Sana head. It's 50 by 50 centimeters. It is a shadow box. You can see it's got some depth to it there. And it has a little spacer system that we explored last week that allows you to put your artwork up at the front of the thing, which is what I've done here. I've 3D printed some brackets that hold the corners, and then I have some 3D printed brackets that hold the 4 panels together. We'll look at that as well. What is coming out of this thing right now is a little bundle of cables. I've got a wired controller, which I'm thinking of seeing if I can get a Bluetooth. This is an 8-bit DOE Bluetooth controller to work instead. And then I have 2 power cables, one for the Raspberry Pi, one for the 5-volt 10-amp DC power for the matrix displays. And then I have a speaker cable running out of here just because I wanted to run it to an external speaker for the show. In the final version, I'm going to run a small USB-powered speaker inside of it. So it won't be super loud, but it should be loud enough to play games with this mounted up on your wall. So ideally, I'll just have the power cables coming out of it. I am considering putting a small power strip inside of here. There's a little bit of space in the back, and having just a single cable coming out of it. So far, it has been quiet and not hot, so I may leave it be. I'm going to put some holes in the back panel only, but I think I don't need to vent it cross ventilation or top like I was talking about before. I've had it running for quite a while and it seems fine. And I think I'll check some of the temperature sensors that are built onto the Pi to make sure that it's not getting crazy hot. I could also add a little heat sink and fan to the CPU if it needs that. So what this is doing, it's running I'm going to go back to this view for a second. It is running the Pico 8 through this POMatter virtual display script. So I want to talk about a few of those things here. So first of all, let's talk about POMatter. So let me switch up to this here. And if we go look at the GitHub for Adafruit, easier said than done. It's not going there. There we go. No? Why is it staying? There we are. It's probably one of the more recent ones that's here on the front page. Adafruit Blinka Raspberry Pi 5 POMatter. So this is designed to use your Hub 75 displays with a bonnet or hat on top of the Pi. And when you install this, and there's a great page that Foamy Guy put together on how to get this all up and running, in the examples there is a Python script called virtual display, and that's what I'm running. So this allows us to essentially run the Pico 8 Fantasy console, which is a 128 by 128 pixel, tiny little thing, and then map it directly with that script to the Hub 75 displays. So if we look back at my Python script, or rather my shell script that I'm running here in Z, and I can clear this so it's not distracting. If you look at this script that's running here, this is running when the machine boots up. The machine is booting just into a command line mode. I don't have it running a desktop at all. It just automatically runs this script, which does a couple things. It does some logging because it wasn't working at first and I needed to figure out why. It turns out I have my paths wrong. It will set the virtual environment. So it sources this source home admin virtual environments. I made a virtual environment called Blinka Venv, and then it runs this activate script. So now we can run our particular installation of the Blinka POMatter, Pi 5 POMatter from Python that way. And then the script runs right here, this virtual display.py, with a couple of arguments, a few arguments. So the pinout is based on an Adafruit matrix bonnet. There are a few different pinouts you can pick from depending on your hardware. The back end is this XVFB, which is the virtual frame buffer, X virtual frame buffer that gets displayed up on your matrix display. We set the pixel width and pixel height. The physical arrangement, this is one called Serpentine, which I believe I have as we look at it this way, the lower right corner is panel 1, and then panel 2 is to the right of it, and then above it and rotated is panel 3, and next to that is panel 4. So it's kind of a U shape. Depending on the software you use to do this sort of thing, you'll see things called U shape, V shape. Ours is called Serpentine. And then the number of address lines is 5. That's because we have the 64 by 64 panels, so 64 by 64 pixel panels, so those require 5 address lines instead of 4. A, B, C, D, E. A, B, C, D, E. The number of planes is essentially the color depth, and since we're running, I believe 16 colors only in Pico 8. I believe it's 16 colors only. I could be wrong on that. But the bit depth does not need to be high, so the refresh rate is higher, and it's actually not quite as bright, I think, when we have a lower color depth on this. This looks good right now. I am going to make a change because there's some work that I think Jepler and Foamy Guy are doing right now on allowing a sort of gamma correction or brightness control to be an argument in this. So I'm actually looking to dim it a bit, especially for on-camera stuff, because it's quite bright, and on camera, if we dim that out, it'll probably pick up a little better. Then the virtual display.py can actually run a command after it. So it basically preps the display to grab your little 128 by 128 space frame buffer and throw it up on the Hub 75. The next thing I'm doing is just launching Pico 8, the 64-bit version of it. So this is where my Pico 8 is installed, Pico 8, 64. And there is a really nice and convenient kiosk mode for Pico 8 called Splore, like an Explorer. And I think I showed this last week. That's what's giving me access to, and we'll switch over here now so I can demo this a little more. That's what's giving me access to a menu system that's activated with that start button on your controller. So I could be playing this game here, which is kind of like a Sudoku type of game, I think. I can be playing this and decide, okay, I'm done with that game. I don't need a keyboard or mouse. I don't need to hit escape and type things in. I can just hit space, go to this little menu system, and head down to Exit to Splore. I'll hit a button on the controller. And Splore has a bunch of little tabs where you can do stuff. So one of them is this Favorites. So I've picked some of my favorite apps, and you can pick them with the controller, and put them into this little Favorites list. So I can go back out there. It's kind of a nice one. This one has some cool music and demonstrates some basic graphics things you can do with sprites, some text. Pause that. You can continue the cart. In some cases you can reset, so we can go back to the beginning. It's like we just launched it. Unfavorite it if you wanted to, and head back to the menu. So these are some that I preset here. And I will say, for this display, the best looking games are the ones that have a dark background. Like if you have pixels on black, let's see, let's play this. This is a snake game. It's a forgiving snake game. Other than, it's okay to hit the walls, just don't run into your tail or any of the blocks. So pause that, head out to Explore. So you can pick games and demos to play on here. I will show Celeste because while it does have a little bit of flickering on camera because of the brightness, you might see a little flickering on there. I'm actually not seeing that in real life. It looks perfect, perfectly still. Oh, watch me die immediately. Okay, wait. So you can see it's very responsive. This is a notoriously unforgiving game. You've got to have sort of frame accurate jumps sometimes, and I've been playing it, and it plays great. So that's a good litmus test for any sort of latency in the system. So other stuff you can do in the Splore is head to different dynamic menus. Like this one here says jam. So there must have been a game jam at some point. If I hit update, it just went online to what the Pico 8 people call their BBS, went up online and found a whole bunch of games. So I can, oops, I'm going sideways. Where's jam? I can play these right from here. Let's see. Oh, here's something called King's Quest. Hey. Ooh, oh my gosh, it's gorgeous. Let's enter the gates. Ah, it's like wizardry kind of thing. It looks like Stephen King, though. It's King's Quest, I get it. Cool. So I'm going to favorite that because I want to come back to that later. So I'll hit the pause or start button. I just favorited it, and now that will exist over in my favorites. Probably at the bottom, or did I just miss it? At the top, K-Quest. That's pretty funny. You can also search for cartridges that are just installed on the system, so you can manually install the P8 files and then go through your there's sort of a virtual disk system in the Lexilawful Pico 8 directory. So I've got the demos and the games. These were the ones that I installed initially. So we can go check those out, or we can, whoops, we can go back up and go to the demos folder, play a little Automata demo there. So those are some of the basics of what's going on with the kiosk system. It works really wonderfully, and it's kind of all you need to do this. It's a good thing because the method I'm using here does not accept mouse keyboard input. We have another method that does, but this one was sort of simpler to set up for me. So in that guide, in fact, let me show the guide here that I'm referring to. Let's go here. If you go to Learn, this one just got updated, so it should be up towards the front. Let me go to View All. There it is. RGB matrix panels with Raspberry Pi 5. So if you go here, there is, by the time you get to basic test in this list, sorry, let me hide the extra me. I think you'll have everything installed that you need, and then multiple matrix panels. So the virtual display.py that I'm using is up in this section. If you want to use that Mirror X display, which is the one that Foamy Guy's shown here with Doom playing, that allows mouse keyboard input as well, and it kind of more directly mirrors a section of the desktop, so you can pick an area of the desktop and have it remapped, but this will do some filtering. So I think for the Pico 8 stuff, 128 by 128 with a one-to-one relationship to those pixels looks fantastic, so I wouldn't want to filter it or process it any, which I think is unavoidable with the RunX display mirror example. I could be wrong on that, but I think, actually that's not quite true. I take that back. Foamy Guy and I did figure out a process of setting a 128 by 128 pixel region of the screen to then map directly, but your mouse control is wild because you're moving across the whole sort of HD display and just trying to keep it in this little area. So mouse control wasn't great in there. Keyboard would work. But turns out we don't really need it if we use this kiosk mode, which I'm excited about. Last thing I'll say on that before we look at how I mounted this and put it together is if you go to Lexilawful Games, lexilawful.com, Lexaloffle, Pico 8, there's actually a couple other pieces of software they've got, but Pico 8 is what I'm using here. It's $15, it's not free, but I've had it for years and never had to pay to upgrade it or anything like that, and it is loads and loads of fun. So you can create content. You'd probably do that more on your computer than on this thing, but if you hit escape with a keyboard, you'll get into the different editors that you see showing up on the screen right there. So code editing, sprite editing, tile, background editing, sound effects, music, all of those are available development tabs right inside of there. So it's all in one. You can do everything right there. Okay, so let's now jump over here and look behind the scenes of the thing, and I'll turn on a little light. So first of all, I'm excited about using this on the Pi 5 because Pi 5 has a safe software power off switch, just like your 386 did back in 1985. So if we want to, we can go into a SSH session and shut the thing down from software, but I don't have to because I'm taking it apart. In this case, I can go ahead and hit the button. Let's lower this here. And I'm going to take this camera out enough so you can see. I used a very big speaker back there because it was convenient. All right, so you can see what's going on here. So right now I didn't modify the back, so I just got it bent up a little bit. This is just some particle board kind of stuff, mat board that came with the frame. And it just has these little typical picture frame bent metal tabs to hold that in place, which I may not trust to the job of holding this thing on the wall, but it's actually not very heavy, so maybe I will. We'll see. But a little extra cut here in the corner to let these wires out neatly, and then I'll probably drill some holes for some venting back there. So that's the backing. And then you can see here is the Raspberry Pi 5, the aforementioned, let me try to fix that focus a little bit, the aforementioned power buttons right here. If I hold this for a few seconds, it just powered off, light goes red, now it's safe to unplug power from it. So I'll unplug my matrix display power and my USB-C power. You do need those two. Unfortunately, you can't run the Pi just off of the power going to the LEDs without experiencing brownouts and dimming and issues. I was trying to see if I could use one of these 2.4 gigahertz game dongles with it. All right, that should be working now. Huge apologies. I'm so sorry about that. That is the worst. I really apologize. I hate blasting your eardrums like that. It is terrible. Yeah, that was batteries dying on both of my mic packs at the same time. So sorry about that. Hopefully all is good, and please forgive me for that. If you can, let me know. Thanks, Nolan Moore. Let me know when the audio died as far as my explanation of what's going on back here. I will keep an eye on the chat. Downhill since Hypnotoad app disappeared from Android, says Joe Hopfield. Yeah, Thin Man says, I'll never wear bone phones again. Yeah, really sorry about that. That was weird because my battery level did not look that dangerous. I checked it before the show and it did not look that dangerously low. But this one really tanked quickly. And I'm using good Energizer batteries too. I don't know why that would have done that. Okay, so let me switch this one back to bench view. And 3 minutes back, someone said in the chat. Okay. So what I've got going on in the back here is the USB-C power for the Pi. I was probably, you heard this part, but I was able to use the software shutdown button on the Pi 5, which is an amazing addition. This has been 10 years that we've wanted this sort of thing. So you can just press and hold that for a few seconds and it shuts down the Pi safely. I've got the power for the matrix panel. So that was 2 cables coming out. I have the USB game controller plugged into there. And one of the things that I was showing is I had this plugged in as well to see if I can use the 2.4 gigahertz controller, if that setup's easier than Bluetooth. But really what I'd like to use is just the Bluetooth SNES style 8-bit DOE controller on this. So that's one wire that won't be there. I was saying the Raspberry Pi 4, I think it was, is when they removed the TRS connector that we had audio, and actually composite video was coming out of that for a while too. But the audio jack is gone. I think you can solder onto these 2 pins here and add a jack if you want. But what I'm going to do for audio is I'm going to try out, Adafruit has a little speaker. It's like a small plastic enclosed speaker that just has a USB cable on it. So it's a USB audio interface built in and a small speaker, and it'll fit nicely in here. Should be loud enough for, you know, simple on-the-wall arcade gameplay. Or we have these, I think they're like $5, little audio interface dongle, gives you USB audio out. This one just worked. I didn't have to do a bunch of annoying setup on the Raspberry Pi. It just plugged in and was found as the sound card, basically. And so I've got right now an external speaker, but again, I could use some small USB powered speakers inside the case with a 3.5 millimeter TRS jack into there. So that's what's going on right there. There's the Pi. The Pi has one IDC cable coming off of the bonnet to the first panel. Then those are linked with the second IDC cable there. Then we use one of the longer IDC cables to go up and then a short one to go across. So that's the data path there. And then they all have their own power supply cable coming from the bonnet there where the 5 volt 4 amp or 10 amp, I think 5 volt 10 amp is coming in. I don't need these anymore. They're just being used as screws because I'm not doing any magnet-y stuff. And then you can see if I move this off to the side, I just have a little 3D printed spacer that clips into there to hide that spot where the mess of Pi stuff is, but maybe you want to see that and you don't need this. And then the rest of the arrangement here is, as you can see, I've got, this is the spacer. Move that up. This is the spacer that came as one square, and you saw it on the show last week. It was just kind of glued at the joints. It very quickly popped apart, but that's okay. It still works as needed. Those are holding these 4 corner brackets in place because I made a little lip for those. Pull all those out right now. And I'll zoom out just a bit so you can see the full picture of what this is. So those were all holding these spacers here. The little corner brackets that you see here, those screw in to 4 panels and wedge right up against these that I've removed. And then they're flush with the backing. So when the backing goes on, it basically holds everything together, presses these against the little lip that's built into the frame there. I think I should be able to pull this out now and leave those behind. So that's the whole, looks like a janky drone or something like that, but that's the panels that just set down into there. Let me find a nice home for these for a second. And I've been wanting to lift these because I got a piece of dust, there we go, under one of those. So these print pretty quickly and easily. They are just able to hold the edges in place, and this lip is what allows these to set them down and hold everything in. So that's it. That's all you need is these 3D printed parts and some screws, and everything goes together. You can print them in fun colors like I did here if you want, or go a little more somber with it. The IKEA frame here actually comes in 4 or 5 colors. There's the red, black, I think white, and then there's a faux walnut vinyl and a faux sort of white oak vinyl. So put this back together like so. I mentioned on the show and tell I was going to, and I talked about this last week, I was going to use some LED acrylic, which I often like for these projects because it diffuses things a little bit, kind of melds the pixels together a little bit. Does not look as good for this application. Just putting these behind this little thin fake glass acrylic piece from the IKEA, I think just looks perfect. So that's one thing you don't have to go out and buy either. And like I said, these frames, this one cost me $15 because it was from the little return section of IKEA. The brand new one cost $20. This one had one minor scratch on the side and was not in the packaging, but otherwise I think it's not bad, not a bad price. It works well for this. And let's put it back together. So these I'm not going to disassemble all of this. The 4 of these go together with this center bracket, and then I join them at the tops or at the edges with these other ones, which have to be slightly different designs because of the arrangement of the IDC cables. As you can see here, I've got a little cutout space because there's IDC cable ports here and there aren't here. I could use this one everywhere, and maybe I'll do that just to simplify things, but this seemed to work out okay. So those are pressed up nicely against there, and then these go back in place. Let's put them where they won't. And so those are what's holding down those sections there. So basically no modification is necessary to the frame. You don't have to drill it, cut it, other than the backing, which I think we'll end up doing, putting some holes in it for running wires and for some breathing. Okay, so these are all at the same height as those little red spacers, these little white things here, which press that all in place. This is a pretty thin piece of acrylic facing that they have there, so you'll see the screen kind of can push out a little bit. It can bow a little bit. I don't mind. It gives it a slightly CRT sort of look. You might be able to avoid that with some other arrangement of your brackets, but I think it works out fine in this case. So we'll place this little blocker piece down there that also kind of wedges it up a bit. And let's plug things back together so you can see it all working again. So that's my audio out. I will turn off this surge strip so I don't fire things up. It's actually not, I haven't tested this in a while. I think as long as you have both the USB-C and the DC power in, it's okay. If you start just with the DC power, the Pi will run off of that DC power and never look to the USB-C port, it seems, which is not ideal. We don't want it running off of that. And I'll probably make a little relief there, a little clip or something to hold that. I could run a zip tie into this bracket or something maybe. Because that's a heavy adapter that I have there. All right, and let's run this controller back in. Doesn't matter where you plug that. I'm also, you can see, I'm not really worrying too much about the Raspberry Pi. It can't really go anywhere. You could probably just secure, I have a little silicone base on it there, but you could secure it with a couple screws if you needed to, or some double stick tape probably. All right, so let's grab this. You can see I am putting this in upside down right now. That's the little hang clip, because there's a little, there happens to be a notch. I have no idea why, but there was a notch up there for the backing. So I'm just using that right now so I don't bend it quite as much. I should probably have checked the face of this thing to make sure I didn't add a whole bunch of dust or pet hair or something. Looks good. Okay, so I can fire this up. Let's see if it turns on and should auto launch. The Pico 8 script. There it goes, and goes straight to Explore, and Explore remembers the last place we were. So I can grab this, start picking things to play. There was a nice little, let me come around the other side. There was a nice little sort of Space Invaders style game that I found yesterday that I was playing on the show and tell. Favorites. What were you called? This one's a Bomberman clone. That's pretty fun. There we go. Cyber Shot. This is fun. Has cool little power-ups. Oh, and did I turn off the audio? Where's my cable? Just why am I not hearing audio? Sound on. Did I plug that into the, you might have seen me and been screaming at me. There's a chance I plugged that audio cable into the microphone input on that audio interface, so I'll go check that later. Okay, so that's the project right there. I am working on the Learn guide for it now, so you should be able to put one of these together for yourself. We have these panels in some different sizes, but I'm not doing it in 3 different flavors. I will share the 3D files if someone wants to go and make one for the 2.5 millimeter pitch or the 2 millimeter pitch one. But this is for the 3 millimeter pitch one, the biggest one that we sell, and has the most impact, I think. Okay, I think that covers it for this. So before I go, again, want to remind you, you can get 10% off in the store by using the coupon code ARTWORK. So head on over to Adafruit.com, throw that in there. Maybe you want to buy this stuff. Get yourself a big discount if you throw in this type of wall-mounted arcade. It's going to take you a Raspberry Pi 5, a bonnet, and the 4 panels, as well as the power supply. Once the guide is out, you'll be able to see the exact bill of materials you need. Thank you. Yeah, Thin Man said, yep, I plugged it into the mic input, so my speaker audio is not going to work right now. Thanks for noticing. Darn it. Okay, that is it for today. Thank you so much. You can swing by tomorrow for a deep dive with Foamy Guy, and I believe Scott will be in the chat. And then there should be a Desk of Lady Ada or other shenanigans over the weekend at various Desk of Lady Ada times. We will be back on Tuesday with a product pick of the week, Wednesday with 3D Hangouts, Show and Tell, Ask an Engineer, Rinse, Repeat. Thank you all so much for coming by. For Adafruit Institute, I'm John Park. This has been John Park's Workshop. Have a great day.